Okay, so day 77 EOC review bell ringer. So again, more EOC questions. So Alex used a quadratic function to solve a problem. The factored form of the function is shown below. What is the positive solution? So remember, to solve means we're going to take both of our factors and we're going to set them equal to 0 and solve for the variable x. And in this case, and you can have parentheses or not, we're looking for the positive solution. So once we're finished, so I want to solve for x. I'm going to first subtract 3 because that's the inverse, and that will get it off the side with the x. And again, the great divide, going back to the very beginning, when we cross that line, it has to be the opposite or inverse operation. 4x is 4 times x, so we're going to divide by 4 because that is the inverse of multiplication. And so x for the first one is a negative 3/4. So already we know that's not our answer because it's negative, and again, we are looking for positive. So coming over here to our next one, we keep our great divide, box in our x to decide what can move first. So if you box in where your x is, anything that's on the outside of that box needs to go before whatever's attached to that x. That's a negative 3, so we're going to add 3 to both sides because that's the inverse of subtraction, or positive is opposite of negative. So we have 6x equals 3. 6x again is 6 times x, so the inverse of multiplication is division, so we're going to divide on both sides. And x equals 3/6, but we're in high school, so we're not going to leave it like that. We can divide the top and the bottom by 3 to reduce that to 1/2. And we're looking for our positive solution, so it would be 1/2. Now, the solution to the quadratic as a whole, all of them would negative 3/4 and positive 1/2. So this would cross the x-axis at negative 3/4 and 1/2. But for this question, the answer is only 1/2 because it's looking for the positive only. Equation of the axis of symmetry. So axis of symmetry, remember, is x equals equation. It's going to be x equals negative b over 2a as the equation. You can also graph it and go find the vertex. It's the x value of the vertex. And the vertex is usually your max or your min, depending if it's a positive or quadratic equation. Remember, if it's a happy, so positive, you have minimum problems. If it's sad or negative, you have max problems. So it's a min if it's a positive, it's a max if it's a negative. This guy is a positive. If you look right there in the front, that 2 is positive, so we know it's going to be a minimum value. And again, just adding some more vocabulary. But the x value of the vertex, we are going to solve with x equals opposite b. Reminder, this is ax squared plus bx plus c. So we're pulling our b from here and our a from here. So opposite b means I'm going to have 3 because it is a negative going in a negative spot. So opposite b, 2 times 2 because that's our a value. So it's going to be a positive 3/4. And it has to be an x equals. Axis of symmetry is x equals, not y equals. So these two are very, very, very bad answers. So we want to make sure that we're doing x equals for the axis of symmetry because it's a vertical line. And just another throwback to some vocabulary. Remember, vertical is an undefined line with an x equals equation. All right, length and width of rectangular garden are represented before. But here, what is the area of the garden in terms of x? So area equals length times width. In this case, we don't know what the area is, but we know that length is x plus 3, and the width is 2x. So we're going to distribute that. 2x times x is 2x squared, and then 2x times 3 is going to be 6x, and we're solving for y. If we set this equal to 0, because that is a quadratic, because of that x squared, we're setting this equal to 0 to solve for x, and that's the way we want it. So we're going to turn that into a 0, because we want to know where it touches the x-axis. So we're solving again. Roots, zeros, x-intercepts, solutions are all the different words. Now, this is a binomial, so not a trinomial. We don't want to use big star or star. So we are going to look for a GCF first. GCF always. When A is not 1, we want to try to find a GCF. And in this case, let's try 2. And 2 times 1 gives me 2. Then I have x squared. And then 2 times 3 gives me 6. And I still have x. Now, if I'm looking at these, I have 1 and 3. Both of those are primes. That's perfect. but they both have an x. The lowest exponent is that imaginary 1, so that I know I can pull out. If I take 1x away from x squared, I end up with x. And then 1x away from that 3x, I end up with 3. You're going to multiply these together, just in case it takes you a couple extra to get down there. It's going to be 2x times x plus 3. And you can check this by distributing it back through, which you should see is right here, right? And then we need to solve it. So actually pushing it together is going to be the answer. So that is the area. I'm going too far. I'm getting excited about factoring. So this is how we know we were in the right spot when we measured it. The area is 2x squared plus 6x. That is the area of this rectangle. If we solve for x, that would just be solving for x, and that would help us find the length or the width. But in this case, we're just going to stop. Sorry, I got a little ahead of myself. So we had our answer right here in the beginning. What is the value of x in the systems of equations shown below? This is probably very likely to be a calculator inactive question. If it's calculator active, you can put both of these in your calculator in Desmos and see where they intersect. But because this is y equals, that means I'm going to put it in the place of y. So y is gone. So we're going to use 5x plus 4, then our y value equals 1. Y is gone because we are substituting in that 1 minus x, because this says y is 1 minus x. And then we're just going to solve it. So 5x is going to come down. 4 times 1 is going to be 4. 4 times a negative x is a negative 4x equals a positive 1. We're going to clean up and combine like terms on each side of the equal marks wherever we can. So like term, and that's going to give us 1x plus 4 equals 1. So we have our x, and that 1 in the front is basically imaginary. Remember, any variable has an imaginary 1 in front of it. So we need to move that positive 4. So we're going to subtract 4 from both sides, and that's going to give me x equals a negative 3. And it just says, what is the value of x? So we're done here. Now, if you needed the y value, you would take that x and plug it in. And you would plug it in the place of x. So it absolutely replaces the value of x. And I'm probably not choosing the easiest of the two equations to do that. But just to show you, so it's going to give you negative 15 plus 4y equals 1. I'm going to add 15 to both sides because that's a negative. And that's going to give me 4y equals 16. Divide by 4 because that is the inverse of multiplication. And so our y value is 4. So the solution to the entire system, that coordinate, is going to be negative 3, 4. But in this case, again, it only asks for the x. All right. Which equation is a line is parallel? So when we see the word parallel, we want to think same slope. Same slope. And that's y equals mx plus b. So that's that m that we're looking for to be the same. If we're looking at this line, it looks like it counts up to 1, 2, 3, up to over 4. So 2 over 4 slope. It is positive. It's increasing as x increases, y increases as well. So looking from left to right, it is going up in the up direction this way. But we want to reduce this to 1/2 because, again, we're in high school and we have to reduce fractions in general. And we can check it. Rise 1, run 2. Rise 1, run 2. Rise 1, run 2 is another good one. And you can see that those dots happen all the way through at the 1/2. Rise over, run. Now, none of these are in slope-intercept form. They're all in standard form. Standard form is when your x and y is on the same side. It's a little harder to find your slope in standard form, so we are going to convert them. Or if you happen to have your calculator, you could type in these guys and see if we can find the 1 over 2 slope in Desmos as well. But I'm going to move that 2x, so it's going to be a negative y equals a negative 2x plus 3. Divide by negative 1. Y equals 2x plus 3. Now, this is the flip of 1/2, so it's the reciprocal. Not the same, but reciprocal. So for this one, we're going to move the x. That's going to become negative 2y equals negative x plus 3. And it became negative because it crossed over, and it's the opposite of that positive. So divide by negative 2. So y equals negative and negative make this a positive 1/2 minus 3 over 2. So 3 1/2. So from here, that means our slopes are the same. So this one's looking pretty good at the moment, but we want to make sure and double check. Also doesn't hurt to practice moving these guys. So 8x, move it. So I end up with 4y equals 4 minus 8x, because it's the inverse as I move it across the equal marks. Divide everything by 4. And that's going to give me y equals 1 minus 8 divided by 4 is 2x. Now this line is definitely perpendicular because this is opposite and reciprocal of that 1/2. So C is definitely perpendicular, not parallel. Perpendicular, remember, is opposite and reciprocal. So if it was positive, it becomes negative, and then the fraction flips, or the whole number flips, because every whole number has an imaginary 1 underneath it. And then last but not least, just to check it, we're going to move our 9x. To move that, it's going to become a negative. So 18y equals a negative 9 minus 9x. Divide by 18. And that's going to give me y equals a negative 9 does go into 18. So it's going to be negative 1 over 2, negative 1/2. And then again, a negative 1/2 x. It's still 9 over 18. And so this again is your opposite slope, but not reciprocal. So this is only opposite, not reciprocal. So not perpendicular and not parallel. So our best answer is indeed B. The cost to rent a construction crane is $750 for the initial rental. Initial rental. That means that's going to be our starting point, right? Starting point. So again, remember, initial rental is a non-negotiable. Non-negotiable. You're going to pay it no matter what. So that's our B value. So plus 750. And we're thinking y equals mx plus b. So that's our B value for sure. Plus, so that means it's going to add. So we're going to have a positive slope. And we have y equals an x plus 750. 250 per hour. So 250 per hour. So that's going to be how you know it's the rate of change, because it's going to change however many hours you're using it. That 750 is not negotiable. It's non-conversational. You are definitely going to have to pay 750. The part that changes is if you have it for 1 hour or 2 hours or 3 hours. So you're going to look for the answer for 250x plus 750. This guy, that means you're non-negotiable in 250, and it was 750 per hour or per minute. So your 750 was the rate of change here. This one, actually, if you simplify it, is going to be C of x equals 10 or 1,000 x. So not a base cost. Everything is relative to hourly change, right? And then this, again, is nothing close. This is going to be hugely overcharged if you use that equation. So remember, y equals mx plus b. You want a slope, and you want a rate of change. I'm sorry, rate of change is a slope. A slope and a starting point. Starting point. Non-negotiable fee. Something you're going to pay every time. All right, for day 78, what is the slope of the line? So slope, remember, is change in y's over the change in x. And you're going to see that maybe like this one day in future math classes. There's a change in y's over the change in x's. And that's your rise over run. You can always graph these points if you don't remember how to algebraically solve for slope and then count it. Now, I like to stack them. And we know it's differences, so we're going to subtract. So negative 9 minus 3 is going to give me a negative 12. 2 minus 14 is going to give me a negative 12. Y always goes on top, so negative 12 over negative 12 is going to give me a positive 1 over 1 slope. So my slope is 1 to 1, and it is positive. So because it was negative and negative, right? So rise over run, 1 to 1 slope, and probably is going to be written like this. And that's not the end of the equation, because we don't know what our y-intercept is here. That part is to be determined later. But for this question, just the slope. Solve without a calculator. This is a calculator inactive question. So we're going to distribute first. It's going to be 3x, and 3 times 4 is going to give me 12. So that's 5x plus 3x plus 12 equals 28. So much like the one from yesterday, we're going to combine our like terms first. It's going to give me 8x plus 12 equals 28. Now again, we have our x, and we want to move what's on the outside of it first. So what's on the outside of it that could move first? So that means we want to move that 12. And so that's going to get these to cancel out. We're crossing that great divide. So we end up with 8x equals 16. Divide both sides by 8. We divide because it's the inverse of multiplication. So x equals 2. So our solution is x equals 2. A school purchases a box of candy bars. Each box contains 50 candy bars. Each box costs $22.50. How much does school have to charge for each candy bar to make a profit of $20 per box? So you can do this a couple of different ways. So I know I have 50 boxes, so I'm going to charge something for 50 boxes, and each box costs $22.50. And when I walk away, I need to have $20 left over. So I need to have 20 when I'm done. I have 50 boxes of candy bars, or 50 candy bars, some number amount that I'm going to charge for those candy bars, minus $22.50, because that I have to pay to buy the box. So this is the equation form of this. And then we're going to get our x by itself again. So we're going to add $22.50, add $22.50, and that's going to be $42.50 over here, right? Equals 50x. 50x is multiplication. So we're going to divide $42.50 by 50, and we get 85. So divide both by 50. So it's going to be 85 cents per candy bar. Now, you could have also, like my brain thinks that I know it's going to cost me $22.50 and I know it's going to cost me $20. So I know I need $42.50 when I'm done, and I have 50 candy bars. So my brain picks up right there if I'm not like necessarily discussing teacher-wise. Just thinking logic, back to like 8th grade and 7th grade, where you would do trial and error and thinking through things, making lists and tables and things of such nature. All right, so when asked to solve a quadratic equation, what are you being asked to do? Factor out a greatest common factor. That is factoring. And you do want to remember to do that. Factoring is what you would do before you can solve. Set the factors equal to 0 and solve for the variables. That is the solving part of, like, the final solving part. So use Pythagorean theorem to find the missing length. This would be more like distance or dealing with triangles. So definitely not quadratics. Find the vertex. That's going to be negative b over 2a, and that vertex might be a conversation of max versus min. It might be how high, or when did it meet its maximum height or minimum height. The max and min we could sub out either way. But that x is going to be the when, the vertex of the quadratic. So remember, this is x. The vertex would be the y, which would be your how high. Decide if the quadratic has a max or a min point. This is just whether or not it's a happy face or a sad face. So a positive graph, again, we have minimum problems because we're happy. Negative graph, sad, so we have max problems. Almost done, guys. Hang in there. One more. Which of the following steps could be used to accurately solve for the value of y? Now, most of us would distribute through, but ultimately, if I want y by itself, disregard my parentheses, this is 3 times. So the inverse of multiplication is division, and then I'm keeping all my numbers very small. Not wrong. If you distribute through, that's fine, because then you have 3y plus 15 equals 45. We're going to subtract 15 from both sides. 3y equals 30. Divide by 3, 3y equals 10. This is probably how most of you do it, but with the choices that are given, it doesn't say to distribute. It says divide both sides by 3 and then subtract 5, because that would be what I would do next here. Get my y by itself, so I got to subtract 5 because it's the inverse of addition, so y equals 10. Still the same answer, and a lot less math if we're being honest up here. So our answer is A, so we're going to divide first. Subtract 5 from both sides, then divide both sides by 3 would be order of operations error. You can't just subtract the 5 out of those parentheses. The parentheses kind of locks that there until you get rid of the 3. Multiply both sides by 3, so both sides by 3 would just be making this side larger than it should be. And then subtract. So this is definitely a really bad one. This is real bad. Subtract 3 from both sides. We don't want to subtract because that is not the inverse of multiplication. You definitely want to divide. So not the inverse of multiplication. So by subtracting 3, you wouldn't actually be getting rid of anything over there where the y variable is. All right, guys, hopefully that got some things straightened out. Always drop in for tutoring. Send me an email or question if you have one.